Hi friends, in this video we are discussing a problem on method of variation of parameters. Okay, the given problem is apply the method of variation of parameters to solve. First problem is y2 plus a square y is equal to cosecant ax. Second problem is y2 plus y is equal to cosecant x. Third problem is y2 plus 4y is equal to cosecant 2x. Fourth one is this is cosecant 2x and this is next one. Fourth one is y2 plus 9y is equal to cosecant 3x. So you observe these all problems are similar. If you are replaced a by 1, then you will have a second problem. If you are replaced a by 2, third problem, a by 3, fourth problem. Okay, so now I am solving the first problem. Then if we replace a by 1, then we will get the solution of a by 1, 2, 3, then we will get the remaining solutions. Yes or no? Right. Now you observe the given problem is y2 plus a square y is equal to cosecant ax. So how you can write this one in the operator form means d square plus a square into y is equal to cosecant ax. Friends, you see this problem we can do in a general method, but they are mentioned clearly apply the method of variation of parameters. So in the general method, first what we will do in the variation of parameters, first we have to compare, we have to rewrite in the standard form. What is the standard form here? You have means d square y by dx square plus p of x into y dash p of x into dy by dx plus q of x into y is equal to r of x is the standard form of the second order linear differential equation. We have to rewrite in this form. Okay, now here you observe directly what is the d square y by dx square quotient? 1. Here also you have 1. So this is in the standard form only. So what is r of x is here? R of x is here this cosecant ax only. The remaining part is as it is. Right. P of x value is here. You have a 0. And q of x is here a square. Now to solve this one, this is in a f of d into y is equal to r of x form or not. So what is the general solution for this? We have a general solution is y of x, general solution of y of differential equation is y of x is equal to complementary function plus particular integral. Okay, now I am discussing the step 1. In the step 1 we need to find out the complementary function. How to find the complementary function? We are taking r of x is equal to 0. Then we will have f of d into y is equal to 0. So to find CF, let y is equal to e power mx be a solution of f of d into y is equal to 0. Then the auxiliary equation is f of m is equal to 0. We will have nothing but y is equal to e power mx. If you are substituted, then we will have m square plus a square into e power mx is equal to 0. So e power mx is never 0. E power mx is never 0. So we will have m square plus a square is equal to 0. So this is f of m is equal to 0 form. So we need to find out the roots for this. Then roots of these are m square is equal to minus a square, which implies m is equal to plus or minus ai. So here you observe the roots are purely imaginary. When the roots are like a plus or minus bi form, then we will write the complementary function is e to the power of ax into c1 cos bx plus c2 sin bx. Yes or no? Now in place of a what I have? 0. In place of b I have a. Therefore in this case the complementary function ycf is equal to e power 0x is nothing but 1 into c1 cos ax plus c2 sin ax. So step 1 is completed. Now step 2. What is the step 2? In the step 2 we need to find out the pi. So friends, in the particular integral we can write the pi directly based on the CF. How you can write means that is a of x into u of x plus b of x into v of x only. So here friends, the given means after getting the complementary function we have to compare this one with c1 u of x plus c2 v of x. So what is u of x now? Here u of x is equal to cos ax and v of x is equal to sin ax. Okay, now what is a of x? We don't know, just we are replaced c1 by a and c2 by b. So we need to find out a of x value and b of x value. So what is the a of x here? We have a of x is equal to minus integral v of x into r of x dx by w of x, and b of x is equal to integral u of x into r of x dx by w of x, where w of x is equal to u v. W of x is called Wronskian. Okay, that is u v u dash v dash. This is the Wronskian for the two variable, right? Whenever here u comma v both are linearly independent solutions, so the Wronskian you will get a non-zero only. You see, now we are solving. U is nothing but cos ax and v is nothing but sin ax. Next u dash is nothing but differentiation of u with respect to x, that is cos ax derivative is minus sin ax into a, so minus a. Sin ax derivative is cos ax into a, so this one. Now cross multiply determinant if you are find out, then cos ax into a cos ax is a cos square ax minus of minus plus a sin square ax. So if you take an a is a common, then you will have cos square ax plus sin square ax is 1, so which is a only, so which is a into 1 means a, which is non-zero. Yes or no? If it is 0, then d square plus d square equal 0 only. Now which is non-zero because u and v are linearly independent solution of the given differential equation, right? So now you know u value and v value, w of x value. So can you find out a of x and b of x or not? Yes. So the values I have written here. Now we need to find out the a of x first. A of x is minus integral of v of x. V of x is meant C2 quotient. What is the C2 quotient here? You have sin ax into, what is the r of x I have? Cosecant ax. Cosecant ax by w of x is a. W of x is we have a. R of x is cosecant ax into dx. So here you observe this 1 by a I can write outside. Minus 1 by a times of sin ax. Friends, 1 by cosecant ax, how you can write actually? 1 by cosecant ax you can write, cosecant ax you can write as 1 by sin ax, yes or no? Into dx. So numerator and denominator getting cancelled. Then you will have minus 1 by a into 1 dx. So what is the integral of 1 with respect to x? With respect to x is x. So you will have minus x by a. Friends, here you see you won't get plus a because plus c you won't get, because even though it is indefinite integral, actually in the complementary function we have c1 and c2 are arbitrary constant. So already we got arbitrary constant, so no need to write here plus c. Clear? Next one, what we need to find? B of x. So b of x is equal to integral of u. U is here what I have? U is equal to c1 quotient. C1 quotient, that is here you have a c1 quotient is cos ax, and r of x is cosecant ax divided by w of x. What is the w of x I have? A. So write down a into dx. Now this is equal to integral of cos ax by cosecant ax is nothing but 1 by sin ax. I am writing 1 by a is outside into dx. Friends, you see this is in a integrand is containing numerator and denominator. Whenever the integrand is containing numerator and denominator, we have to remember the formula integral of f dash of x by f of x dx. Nothing but the denominator derivative, if it is in the numerator, then we will write log of denominator. Log of the denominator, mod f of x. Okay. Now here you observe what you have in the denominator, sin ax. What is the sin ax derivative? A into cos ax. Is there a is in numerator? No. So we have to rearrange. How you can write this is multiply with a and divide with a. If I divided, then I will have 1 by a square. Inside if you written a, okay, a and a getting cancelled, you see. If you are replaced, then you will have same answer. You see, a and getting cancelled, then you are getting numerator above equation. So there is no change. Now this is like a denominator derivative in the numerator. So what you will let? Log of denominator. What is the denominator you have? Sin ax. Is it clear? Sin ax. So now you have which value? B value. In the previously what I have? A of x. Now we have B of x. So this A of x value, B of x value, we need to write in the particular integral. What is the particular integral you have? Pi is equal to A of x into u of x plus b of x into v of x. So what is the a of x I have? a of x is equal to minus x by a. So minus x by a into u of x means cos ax plus b means 1 by a square into log of sin ax. So we have to write these two values, means a particular integral we have. In the previously what I have? Complementary function. So in the general solution we have to write a complementary function and particular integral. Okay. So here I have written complementary function and the particular integral. Okay, this is the solution for d square plus a square into y is equal to cosecant ax. But friends, you see, they are given another problem. That is, second problem is d square plus 1 into y is equal to cosecant x they are given. Yes or no? So what we have to do here? In the general solution, we have to put a is equal to 1. Then we will have y of x is equal to c1 cos ax plus c2, a means here 1, sorry, c1 cos x plus c2 sin x minus x by a. X by a means x by 1, that is x cos x plus 1 by a square is nothing but 1 by 1 is 1 sin 1 into x. Okay, into log of mod sin x. So this is the general solution for d square plus 1 into y is equal to cosecant x. Next, third problem they are given d square plus 4 into y is equal to cosecant 2x they are given. So what you have to substitute now? We have to substitute a is equal to 2 in the general solution of d square plus a square into y is equal to cosecant ax. Then you have the general solution is y of x is equal to excuse me, c1 cos ax, a means here 2x plus c2 sin 2x minus x by a means 2 cos ax. A is what here? Cos 2x plus 1 by a square is nothing but 1 by 4 sin 2x into log of mod sin 2x. Is it clear for everyone? Now, fourth problem they are given d square plus 9 into y is equal to d square plus 9 into y is equal to cosecant 3x. So in place of a we have to replace 3 from the given problem. D square plus a square into y is equal to cosecant ax. So if you are substituted, then the general solution is y of x is equal to c1 cos 3x plus c2 sin 3x minus x by 3 times of cos 3x plus 1 by 9 times of sin 3x into log of mod sin 3x. Is it clear for everyone? So this is the procedure and to solve the differential equation in the variation of parameters. Friends, you see, the given problem is d square plus a square into y is equal to cosecant ax. So r of x is here, we have a cosecant ax. Then you can replace this one with sin ax, tan ax, cos ax, next secant ax, like that we can do. Okay, in the next problems we will solve these type of, like r of x replaced by sin ax or cos ax. Okay, right. Thank you for watching this video.